put this on the recording. Similar figures are basically just like you take a figure and you blow it up by scale factor. The sides would be proportional and the angles would still be the same. You don't change the angles when you just blow it up. It's like taking, when you're working maybe in Word and you put a photo in your document and you drag the corner of it to blow it up or shrink it to fit your document. You're just using a scale factor there to make it fit your document. So similar triangles are like that. We've got a lot of reasons we can show things are similar. If all the sides are proportional, like that side, if I multiply the small side to get the big side, and then I go and I take the same number that I multiplied by the first time, bless you, the same scale factor, and if I find the same scale factor exists between that side that I marked with 2 marks and then on the large one and the small one, if it's multiplied by the same amount, and then over here, if these sides that I marked with 3 marks, if they're multiplied by the same scale factor, we would say all the sides are proportional, and so by side, those triangles would be similar. They're not the same size, but their angles are the same, and the sides are proportional to one another. You basically, what the proportional means is you use the same scale factor, multiplied, take the sides of the first one, multiply by the same scale factor to get all the sides of the second one. So things like side, angle, side, angle, angle, side, and then one that you didn't have before, angle. If 2 angles match up in 2 triangles, doesn't that mean the third angle is going to match up? Because you're subtracting both of those totals from 180 in both triangles. So actually, angle is a reason that we know that these 2 things would be what we call similar. And that means the sides are proportional. And the symbol for similar is that little symbol right there. It's kind of like when you write congruent, when you make your estimation sign with those little 2 squigglies, when you're estimating a value, it's like that, except you're just using one of those. So that's when you see that symbol, this means similar, okay? So that's kind of the background for this. You've listened to a couple of videos already on this, but then this new worksheet kind of goes through all the reasons all at one time, so you kind of get them all at once weekend. So just thought we'd get started on this one. If you look at this worksheet, it says determine if the triangles are similar. If so, state the reason that would prove this true. So you've got number 1, you've got RKE, and then you've got a bigger one, and they were nice. They turned them the same, they oriented them the same for you. Sometimes they turn them all different ways, and you have a hard time reading them. So this is 60, and we see that it matches up with a 60-degree angle over here. This one's 80, and we see that it matches up with an 80-degree angle over here. So these would be similar. We would say, yes, they're similar. And how we show that is we say the reason they're similar is angle. That's what goes in that first blank. I could say angle, but angle, you don't even have to say all that because you know if 2 are congruent, the third's going to be congruent. So you really only have to check for 2 angles. And then you have to write your similarity statement. That's what you see next, that next little blank. And you just have to match up the things that match up. Like R is 60 degrees, it matches with M is 60 degrees, right? Then if I go up to K, it's the 80-degree angle, so I need to put S next. And then E is going to match up with T. So you have to write the statements where the parts match up. You're showing which sides are proportional to which sides. You could undo that similarity statement and get all your sides information really easily there. Okay, so like number 2, you have these 2 triangles, and they did draw them where they look much alike. Are these proportional? What do you think? Are these similar? Let's look at the sides. How am I going to get from 12 to 4? divide by 3 or multiply by a third, right? If I'm going from big to little here. So we can say divide by 3. We know that's the same thing as multiply by a third. I'll just put times a third, because remember scale factor was what do you multiply by? So 2 times a third would give me 2/3. Hey, that one matches 2, doesn't it? What would 9 times a third, or 9 divided by 3 be? 3. So those all match up. The sides are proportional. So we would say these two triangles are similar by side, 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 because it was the 3 sides that that we found were proportional to each other that let me know these were similar. And I didn't put my letters on here, so I'm going to do that while y'all are writing. R, S, T. Okay, so we're going to match up. Let's say I'm going to write the similarity statement, and I want to start and go from S to R on the first triangle. Well, the side that matches up that would be what, from M to Q on the second one? So before I used angles to kind of figure out what went together. Now I'm matching up sides. I'm going to say, hey, I'm going to go down from here and go up to R. So here I'll start at M and go up to Q. And then from R I'll go down to T. So I'll write T in. Oh well, both of them had a T. Okay.
Is there a specific way we have to order it?
Yeah, you do. You have to. That's a good question. No, you can start anywhere. I misunderstood your question. Yeah, you could have said RTS matches QTM, or you could have said TSR matches TMQ. So there's 3 different ways to write those. Are you like blocking him on purpose, or he was like doing this around you? Okay, we know this. We know B is a right angle, and we know D over here is a right angle, even though my D looks like a P. So if they're going to match up, it's going to be B and D are going to match up, right? They also mark angle C and angle E as being congruent. So are these two similar? Yes, because I have 2 angles that are congruent. So my reason would be AA again. And I would say, okay, triangle B, let's match it up. I'm just going to put the similar out here. B matches up with D. If I went to C next, then I would need on that lower triangle to go to E, because that would match those 2 angles up. And then BC, A would have to match up with C there. Okay.